So for this question, we're taking those same two blocks, the 10 kilogram block and the 15 kilogram block. Instead of them being pushed, we put them on a pulley system. Now normally we say like up is positive, right is positive, like we define a direction as positive, but the interesting thing about strings, they allow us to change the direction of a force. So in this case, instead of thinking like up or down is positive, I'm actually going to look at the system and say, think about it logically. So because the 15 kilogram mass is on the left, we know this pulley system is going to rotate counterclockwise around that pulley. So instead of saying that up or down is positive, I am going to just make a little note to myself that this counterclockwise direction, this is going to be my positive direction. So I know acceleration's in this direction. So I'm going to say counterclockwise is my positive direction. Okay. So we're going to look at the system. Let's actually draw the forces acting on it. So a 10 kilogram block, it's going to have some force of gravity going downwards. And we can call this object 1, this is object 2. So we call this F1. However, this one's going to have an F2. It's going to be bigger. I'm going to draw a bigger arrow because the mass is bigger. However, because these two objects are connected to each other, we're going to have that Newton's third law of force. The rope 15 kilogram block is pulling on the 10 kilogram block, but the 10 kilogram block is pulling on the 15 kilogram block. So whenever we talk about forces along a string, we call that tension. So I'm going to have a tension force going up like this, but it's going to be equal and opposite to the tension force acting on the other block. So we're going to look at the whole system to find the acceleration. So look at whole system. So I have sum of the forces. This is equal to mass times acceleration. So because we're looking at the whole system, to make sure we don't forget, we're looking at the total mass is being accelerated. So I put a little t there, capital T, to represent total. So you say, what forces are causing this acceleration? So F2 is making it go counterclockwise, but F1 is resisting that counterclockwise direction. One other thing to note is the tension forces are also in play. So I have plus T, because the right tension force is in that clockwise direction, but there is a tension force in the opposite direction as well. So again, when we look at the whole system, we can ignore those equal opposite forces, those contact forces. So these actually are just going to cancel each other out. We're left with MTA is equal to F2 minus F1. So our total mass is going to be 15.0 kilograms plus 10.0 kilograms times acceleration. And the force F2 is going to be 15 kilograms multiplied by 9.8, 1 meters per second squared, minus the 10.0 kilograms multiplied by the 9.81 meters per second squared. So when all is said and done, we solve for acceleration. We have 15 times 9.8 multiplied by 10 times 9.81. And we're going to divide by 25. We get an acceleration of 1.96 meters per second squared. Again, we always ask ourselves, does the answer make sense? You know, if a object was just falling on its own, if we just had that 15 kilogram block and we knew we were just going to drop it, that would fall at 9.8 meters per second squared. However, it makes sense that if there's something resisting it, it's going to go down slower. Okay, so now we're going to say, what is the tension in the cord? So to find the tension in the cord, we have to look at just one of the blocks. We have to look at either the 10.0 kilogram block, or we can look at the 15 kilogram block. But we will do both. So question B, tension, or action-reaction forces. And this is actually, if we look at each one separately, we actually see this is just the elevator problem. So we have two blocks. If we look at just the 15 kilogram block, or if we look at the 10 kilogram block. So what we need to first recognize is that for the 15 kilogram block, that kilogram block, because the system is going counterclockwise, the acceleration acting on the 15 kilogram block is actually downwards. So what I know from this is I have some F2 downwards, and we have some tension holding it up. If I was looking at the 10 kilogram block, what we need to recognize is the acceleration is actually upwards. As the 15 kilogram block falls, the 10 kilogram block is going to rise upwards. So it's going to have some tension force, and force of gravity is downwards. So F1 we call that. It says right our equation, we have sum of the forces is equal to mass. Again, for the 15 kilogram, this is mass 2 times acceleration. And we can see that F2 is causing this thing to go downwards, and it's being opposed by tension T. So just like in the elevator problem we saw in day 1, we see that T comes out to be, that's just going to equal to F2, which is just M2G minus M2A. So we get a value of mass 2, that's 15 kilograms. So we get 9.81 meters per second squared, and we're subtracting that acceleration, subtracting the 1.96, and we're multiplying that all by 15. We get 118 newtons of force in the rope. And this is important because if you're ever designing something that must rise or fall, you need to find out like what will the middle piece, what's the inside pieces, what forces will be exerted, because you don't want things to fail or break. If you use too weak of a rope and not realizing what force is going to be exerted on that rope, that's when problems occur. So sum of the force is equal to mass times acceleration. This 10 kilogram block we call the M1. In this case, because acceleration is up, I like to think of the direction of acceleration as positive. So I have T minus F1. So you can see that T is going to equal to M1G plus M1A. So look, we can see that we're just going to be adding the gravity and acceleration together. So we get G plus A. So you get 9.81 plus the 1.96. Multiply that by our mass, which is 10 kilograms. Guess what? 118 newtons. Doesn't matter which one you do, they come out with the same answer. And if you had different values, you know you did it wrong.